So in the last video we talked about ratio tables and cross multiplication, and we said that 2 divided by 4 is the same as 10 out of 20. Okay, so we said that these fractions were equal. Now we also know that this is also equal to a half. Okay, we can set these in a bigger ratio table that has more than 2 columns. Okay, so we can make a ratio table like this that has 1, 2, 2, 4, 10, 20. And what you'll see if we do this is that that relationship between the sides between the boxes in the table stay the same. So if we go like this, okay, we get 1 times 4 is equal to 2 times 2. So 1 times 4 is 4, and that's equal to 4. Okay, lovely. Let's try another one. So if we instead do this combination, then what we see is 2 times 20 is equal to 4 times 10. 2 times 20 is 40, and that's equal to 40. And we know that that's also true. We can go one step further and we can multiply all the way across. Okay, so in this third example, we get 20 times 1 is equal to 2 times 10. 20 times 1 is 20, and that's equal to 20. Alright, so ratio tables, when there are more than 2 columns, can be used across any combination of those, okay, as long as you stick with the same 2 columns when you multiply. Okay, so as an example, if we have a ratio table where we have say x plus 3 and 5, 2x plus 1 and 4, and then let's put a 2 and a y here. Oh, I don't know what happened there, and a y here. Okay, let's see what we get. So in this example, in order for us to calculate y, we need to first find x. Okay, because otherwise we're going to end up with 2 variables. So we need to get rid of one variable first. So we're going to start by doing this multiplication here. Okay, so we get 4x plus 3 is equal to 5 2x plus 1. Okay, so 4x plus 12 is equal to 10x plus 5. As you know, I like to remove the smallest variable term, so minus 4x from both sides gives us 12 is equal to 6x plus 5. 12 minus 5 is 7, so 6x is equal to 7. If we minus 5 from both of them, and now we're going to divide by 6. Okay, so we've ended up with a horrible number, but that's okay. So we're going to get x is equal to 7 over 6, and I'm going to leave it like that. Okay, so now that we've done that, we now know our value for x. Okay, we can use this to now do the second part of this multiplication, okay, to find y. Now, in order to find y, you need to multiply across either the first combination like this, or you can do it across the whole way. Okay, it's up to you. It doesn't really matter. Now, in this case, because we have a fraction for x, I think it's probably going to be easier if we use this combination. Okay, but we can actually show that you get the same answer either way. All right, so we have y, x plus 3 is equal to 10. Okay, now x was 7 over 6, so we're going to get y 7 over 6 plus 3 is equal to 10. In this case, I like to multiply my brackets out, so we're going to get 7, 6y plus 3y is equal to 10. And here we have a fraction, and as you guys learn in the first unit, what's really nice when you have a fraction is to multiply by the denominator in order to get rid of it. Okay, so everything's going to multiply by 6 here, then we get 7y plus 6 3s are 18, so 18y is equal to 60. Okay, so 7 and 18 is 25y is equal to 60. Okay, then we can just divide both sides by 25, and we have y is equal to 60 over 25. Now in this case you do need to simplify because this is not the smallest ratio that we can have here. Okay, both of these can be divided by 5. 60 divided by 5 is 12, and 25 divided by 5 is 5. You can either leave it like this, or if it's in a context where you need to find a length or something, then you should convert it, in which case you have 2 and 2/5. Okay, but I do not want to see any of these written as decimals. Okay, so this is how we do it when you're working with a ratio table that has more than 2 columns. Okay, so we can do these with 3, and that's what you're mostly going to be working with. Just make sure that you remember you need to find one variable before you do any multiplication that involves 2 of them. Okay, good luck.